This topic is the foundation of any effective supply chain management. Modern logistics is no longer limited to the physical movement of goods. Its driving force is information. Data serves as the true fuel of modern logistics. Thousands of documents are generated daily during operational activities: invoices, bills of lading, packing lists. This entire array of information must undergo a mandatory transformation flow from physical documentation to digital scanning, and finally to the construction of a structured data architecture. Our key goal today is to explore the evolution of tools for working with this information, from simple spreadsheets to a comprehensive analytics architecture. We will understand how to properly organize logistics datasets so they become a reliable basis for making accurate and swift management decisions. Modern companies invest significant resources in implementing powerful corporate systems: ERP for enterprise management, WMS for warehouse operations control, or TMS for transport management. These systems act as a reliable foundation, a kind of digital fortress. Their main function is to ensure stability, automate daily processes, and maintain strict operational standards. However, this rigid standardization has a downside. The systems often prove to be too inflexible when the need for rapid adaptation or analysis arises. In real-world logistics practice, non-standard, unpredictable situations regularly occur. For example, it may be necessary to urgently assess the financial consequences of a sudden transit route blockage, or to identify the non-obvious reason for a sharp spike in damages to a specific type of product during delivery. Corporate systems usually do not have ready-made report templates for such specific queries. In such cases, raw datasets are unloaded, exported in .csv or .xlsx formats. It is at this stage that spreadsheets become a key tool, functioning as a universal Swiss Army knife. They provide maximum flexibility and are the basic environment for conducting ad hoc analytics, the operational resolution of one-time unique tasks here and now. Thus, a clear balance is established. Corporate systems manage large-scale processes, while spreadsheets remain an indispensable tool for analysts for the targeted resolution of specific problems. The biggest mistake made when working with exported data is trying to turn it into a human-readable report directly within the source dataset. It is necessary to clearly distinguish between tables created for human visual perception and tables prepared for machine processing. Analytical algorithms, pivot tables, or BI systems are completely incapable of recognizing colors, fonts, or indents. What looks aesthetic and understandable to an employee, for example, empty rows to visually separate product batches or intermediate totals at the bottom of the page, turns into informational noise for a database. Consider a typical situation. In a shipping schedule, a cell with the vehicle number is merged for 10 different delivery notes traveling in the same truck. A person easily reads this visual logic, but a computer algorithm, when sorting or searching, will assign the vehicle number only to the first record, while the other 9 will receive empty values and simply be excluded from the analysis. Therefore, the ideal structure for further work is a continuous, dry dataset. The priority here is not beauty or convenience for the eyes, but strict machine logic, containing only raw data without any visual design elements. For exported data to become the basis for deep analytics, we must bring it to the form of a so-called flat database. Unlike complex relational databases, where information is scattered across dozens of related tables, in our case, we aim to create a single, continuous, two-dimensional array. The main principle here is that all information necessary for a specific study is consolidated onto a single sheet. Such a structure is a technological foundation, as it ensures the dataset is fully ready for use in pivot tables and for its seamless integration into modern BI systems. This transforms the table from a simple list of records into a powerful analytical asset. For this flat model to truly work, it must strictly adhere to the 4 golden rules of a machine-readable structure. The first rule requires that one row must correspond to exactly one unique record or transaction. In logistics, this could be the movement of a single pallet or one stock keeping unit, SKU, within a specific order. The second rule governs the structure of columns. One column must contain only one attribute or variable. This means we strictly do not mix different types of data in one cell, for example, weight and date. Each metric gets its own separate column. The third rule emphasizes the mandatory presence of unique identifiers, or primary keys, unique ID. These are order numbers, bill of lading numbers, or SKUs that allow the system to unerringly identify a record or link it to other datasets. Finally, the fourth rule is the absolute homogeneity of the dataset. The table should not have any empty holes, intermediate totals, or merged cells. Adherence to these principles ensures that the data will be correctly interpreted by any algorithm without errors. Although classic flat tables remain the standard for analytics, we are witnessing a rapid evolution of tools and the emergence of new generation hybrid systems such as Airtable or Smartsheet. These platforms successfully combine the visual simplicity and intuitiveness of a regular Excel sheet with the architectural power of relational databases. The key advantage of such systems lies in the way they combine information. Instead of building complex and often brittle lookup formulas like VLOOKUP to consolidate data from different sheets, we use reliable direct links, known as linked records. Imagine that a row with a customer's order, for example, Dawn LLC, is not just text, but an active link. By clicking on it, you instantly get access to all related information, the manager's contact details, delivery address, or the history of previous shipments, which are stored in a separate linked table. This allows for the construction of flexible yet stable management systems, where data always remains synchronized and integral. Any quality analytics begins not with building complex charts, but with the thorough preparation of the source datasets. In this work, we are always guided by the fundamental principle of GIGO, which stands for garbage in, garbage out. If you build an analytical report or a pivot table based on dirty, unverified exports, the result will also be flawed. In logistics, the cost of such an error is extremely high. Incorrectly recognized weight, duplicate orders, or errors in SKUs lead to incorrect management decisions, which automatically translate into financial losses for the company. That is why data normalization, the process of cleaning and standardizing it, is not just a technical procedure, but a mandatory stage that must precede any analysis. Only a clean and structured dataset can be a reliable source for modeling supply chains. The traditional approach to analytics, which involves daily manual exporting of files, saving them on a local computer, and then forwarding them by email, is now considered inefficient and outdated. This manual mode creates significant risks. Data quickly becomes outdated, and during transfer between different users, it is easy to make mistakes or lose part of the information. The modern standard of work requires a transition to automated data flows. Instead of downloading a new CSV file each time, we use built-in connectors, such as Power Query, to connect directly to WMS or TMS databases via secure APIs. This allows you to set up the transformation chain once, after which the information will be updated automatically, for example, every hour or every time the file is opened. Thus, the analytical dashboard always reflects the real state of affairs in the supply chain without any human intervention in the data transfer process. One of the most insidious problems when processing logistics data hides where we least expect it, in plain text. For example, if an operator, while manually entering a city name, accidentally adds a space at the end of the word, the entries Kyiv and Kyiv space will look identical to the human eye. However, for computer algorithms, these are two completely different objects. This creates critical obstacles during analysis. When we try to group shipments by destination, the system will produce two separate rows instead of one, which will significantly distort the final statistics. Moreover, classic lookup functions like VLOOKUP will simply fail to find the required value and will return an error if even one such invisible enemy is present in the database. A similar situation arises with case sensitivity. The name of the same counterparty, recorded as Logistics LLC and Logistics LLC, will be perceived by the system as different companies. To overcome these barriers, methods of forced data set cleaning are mandatory. Using tools to remove extra spaces, particularly the trim function, and converting all text to a single case using the upper or lower functions allows for the complete normalization of data, making it transparent for further machine processing. Another critical obstacle on the path to quality analytics is the incorrect recognition of data types. Often, corporate systems export metrics in a format that a spreadsheet processor perceives only as plain text. Let's consider a classic example with cargo weight. If a cell contains 100 kilograms, for us, it is an understandable physical quantity, but for the program, it is just a sequence of characters, i.e., a text string. Attempting any mathematical operation with such a record, for example, summing the weight of the entire batch using the sum function, will result in the cell being ignored or a hash value error. To avoid this, numbers must be physically separated from the units of measurement using parsing tools. Only clean numerical values allow for the correct calculation of transport load or freight cost. Dates require special attention, as they are the most complex data type in international logistics. Due to differences in regional settings, the entry 05/04 can be interpreted as both April 5th and May 4th. In a properly configured table, a date is stored not as text, but as a unique serial number. This is critically important because only this format allows for error-free filtering of datasets in chronological order and accurate calculation of transit duration or storage time of goods in a warehouse. Thus, context and correct typing are the foundation without which mathematical calculations in logistics become impossible. Quite often during analysis, we face a situation where a single export does not contain all the necessary information to make a decision. For example, a warehouse report might only contain the order number, product SKU, and its quantity, but it lacks data on the weight or category of the product. This information is usually stored elsewhere, in the product master data. To get the full picture, we must perform a consolidation, that is, combine these disparate datasets into a single cohesive puzzle. This process is like building bridges. We choose an identifier common to both tables, for example, a unique SKU, and use it to stitch the data together. Today, it is no longer necessary to use old and less reliable methods for this. Modern tools, such as the XLOOKUP function or the Power Query add-in, allow you to automatically find the required SKU in the master data and instantly pull in the corresponding weight or volume into our main shipping table. Only after such data enrichment is the dataset considered fully ready for building final analytical reports and calculating key logistics indicators. Historically, working with spreadsheets in logistics was accompanied by constant version chaos. Work folders often accumulate dozens of files with names like report-final, report-really final, or report-v3-edited. When a document is sent by email between different departments, it instantly becomes static and outdated. This inevitably leads to logistical failures. For example, the warehouse might start shipping based on an old plan, while the dispatcher has already created a new one. The transition to cloud platforms completely eliminates the versioning problem. The file does not physically travel between computers, but exists as a single instance on a cloud server. This forms a single source of truth. This means real-time synchronization. As soon as a dispatcher in the central office enters the assigned vehicle number, a warehouse worker on the ramp instantly sees this change on their screen. There is no longer a need to refresh the page, wait for emails, or clarify data by phone. All process participants are always working with the most current information. Working in a shared cloud environment, we gain not only speed, but also a high level of security and control over data. In logistics, it is critically important to protect datasets from accidental or intentional damage, so we use flexible management of access levels. For example, a logistician has full editor rights for promptly entering new orders and changing tariffs. A sales manager, in the role of a commenter, can leave important notes about client wishes without the technical ability to change the main figures or break the structure. And a warehouse employee, in the role of a viewer, sees the current picking plan for the day without any risk of accidentally deleting a row or changing an order status. Additionally, we can use protection for specific ranges to permanently freeze complex cost calculation formulas, leaving only the status columns for line staff to edit. However, the real insurance policy for an analyst is the detailed version history and change audit. The cloud system keeps a log of every transaction. We can always see who made a change and at what time. If a serious failure occurs, for example, logical connections in the entire dataset are broken due to incorrect sorting, a manager can restore the file to a previous, intact state with literally one click. Such transparency and the ability to roll back changes allow the team to work confidently and securely, overcoming information barriers between departments. The biggest technological breakthrough in recent years has been the integration of large language models directly into the interface of cloud spreadsheets. Now, for deep analysis of datasets, it is not necessary to be a programmer or to perfectly know the syntax of complex formulas. We are moving into an era of direct communication with data in natural language. For example, instead of writing multi-level filters, a logistician can simply ask an AI assistant, "Show me bills of lading delayed by more than 2 days." The system will instantly understand the context, apply the necessary filters to the relevant columns, and display the result. Moreover, the assistant is capable of performing calculations and visualizing them on its own. It can not only provide a list of delays, but also immediately build a chart of the reasons for these failures, grouping them by responsible departments, logistics, warehouse, or supplier. Such a transformation from static cells to an intelligent conversational interface turns the spreadsheet into an operational control panel. This allows a specialist to instantly test operational hypotheses, promptly investigate incidents in the supply chain, and find hidden patterns in the daily flow of numbers. Concluding this topic, it is important to realize that in today's reality, data structure is becoming the new literacy for a supply chain management specialist. We are moving to a Logistics Specialist 2.0 skills format, where proficiency with information processing tools is as basic a requirement as knowledge of regulatory frameworks or warehouse equipment. This new standard is based on 3 pillars. First, clean architecture, understanding how to transform a chaotic set of records into a strict, machine-readable dataset. Second, automated hygiene, which allows for the abandonment of manual error correction in favor of systemic cleaning algorithms. And third, cloud collaboration, which finally breaks down information barriers between departments and creates a single environment for decision-making. Today's spreadsheet processors are no longer just digital replacements for paper records, but self-sufficient data control panels. The ability to freely manipulate raw sources is a key skill of the future. One should not blindly rely only on pre-made dashboards generated by large corporate systems, as they often provide a too generalized picture. A true professional must be able to independently dive into the primary sources to critically assess the real state of affairs, investigate incidents, and find hidden patterns in the daily flow of numbers.